Hi there, and welcome to this lesson on Pure Mathematics 3. And in this lesson, we'll be looking at how some integrations. If you're trying to integrate trigonometric functions, then it is sometimes useful to use a trig identity to simplify the integration. And of particular importance is the use of the double angle formula for cos 2a. Cos 2a is equal to cos squared a minus sine squared a, which can be rewritten in two different ways. So in terms of sine squared, you can write it as cos 2a equals 1 minus 2 sine squared, which can be rearranged to give sine squared in terms of cos 2a. So sine squared a is equal to a half minus a half cos 2a. Similarly, cos 2a can be written as 2 cos squared a minus 1, and this also can be rearranged, this time to give cos squared a in terms of cos 2a. Now, these two formulas are extremely important in integration. Frequently, we need to integrate sine squared or cos squared, and it's using these identities, which is the method that we use. So, for example, if you had to differentiate sine squared x with respect to x, have a go at doing that using the identity. So pause the video and then come back to me when you're ready. Okay, let's have a look. So sine squared x is a half minus a half cos 2x. And the moment you've used the identity, you've changed an integration that we couldn't do, integrating sine squared, into an integration that's very straightforward to do. So integrating this will give us a half x minus a quarter sine 2x. If I differentiated the sine 2x, I get cos 2x, and I get times by 2 when I use the chain rule. And 2 times a quarter gives me the half there. Okay, if you had to use exact values, so if you had to find the integral between pi by 4 and pi by 2, same thing. So it's a very similar question, but have a go at it and come back to me again when you're ready. Okay, let's have a look. So as before, sine squared is a half minus a half cos 2x. Integrating that gives us a half x minus a quarter sine 2x. Then we need to put in the limits, pi by 2 and pi by 4. That will give us pi by 4 minus a quarter sine pi. Take away pi by 8 minus a quarter sine pi by 2. Now sine pi is sine of 180. That'll be 0, so that term will vanish. Sine pi by 2 is 1, so that term will just become a quarter. And all of that simplifies to pi by 8 plus a quarter. Okay, example 3. Find the integral of cos squared 3x. And it's the 3x that you'll need to be slightly careful with. But I'll let you have a go. Pause the video and then come back to me when you're ready. Okay, the first thing to do is to rewrite cos squared 3x in terms of this formula. So cos squared 3x is the same as a half cos 6x plus a half. This we can then integrate. Integrating this will give us 1 over 12 sine 6x. 1 over 12, because if I differentiated that, I get the cos 6x, but I'd also have to times by 6 when I differentiate the 6x using the chain rule, plus a half x plus the constant. Example 4, use the identity sec squared equals 1 plus tan squared to find the following integral. So the integral of tan squared. I'll let you have a go at this. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. Well, tan squared equals sec squared minus 1. And the moment you use that identity, suddenly it becomes very easy to integrate. Because if you differentiate tan, you get sec squared. So if you integrate sec squared, you'll just get tan x. And integrating the minus 1 gives us the minus x. And that's the question done. Question 5. Use the identity sec squared x equals 1 plus tan squared x to find the following. So it's the integral of sec x plus tan x all squared dx. I'll let you have a go at this. Pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. Well, the first thing to do is just to multiply out the brackets. So sec x plus tan x all squared will give me sec squared plus 2 sec x tan x plus tan squared x. Tan squared x is sec squared x minus 1, using the identity up here. And joining those together will give me the integral of 2 sec squared x plus 2 sec x tan x minus 1. Both of these are standard integrals. So integrating the 2 sec squared x just gives me 2 tan x. Integrating sec x tan x gives me sec x. And integrating minus 1 gives me minus x. And again, that's it. That would be the answer. Okay, example 6, using the identity sine 2a is equal to 2 sine a cos a. Have a go at calculating the integral of sine 2x cos 2x between 0 and pi by 4. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. Now, the first thing to do is use the identity. It's a little bit confusing because we've got 2x here, whereas we've just got a here. So we've got double the angle, so this will also be double. So we'll get sine 4x. Also, the identity normally has a 2 here, so the 2's moved to the other side, which is why we've got a half sine 4x. That means the integral of this is the same as the integral of a half sine 4x, and that we can integrate by using normal methods. So integrating the sine gives us cos. We also need to divide by 4, because if we differentiated the cos, we'd get times by 4 when we use the chain rule differentiating the 4x. And also there's a minus, because if you differentiate cos, you get minus sine. Putting in the limits would give us that. Cos pi is the same as cos 180 degrees, which is minus 1. So that gives us plus 1/8 here. And cos of 0 is plus 1, so that gives us another plus 1/8, which gives us 1/4 in total. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 153 and have a go at exercise 7C. Thank you very much for listening, and cheerio.